Alright guys, so in section 11.2, we're going to talk a little bit more about circles, and in particular, we're going to talk about some of the properties of tangents. So remember, tangents are lines which intersect our circle at only one point. And so let's first talk about the relationship between your tangent and the radius for a circle. So if a line is tangent to a circle, then it's going to have to be perpendicular to the radius drawn to the point of tangency. In other words, looking at this diagram, you've got your circle with center P, you've got a radius PA, and then you've got your line AB, which is tangent to it. And what that means is that the angle that's formed between PA and line AB is going to have to be a right angle. So let's talk about how we can use that to solve for some given information. So looking at each of these examples, we're going to be given that the line AB is tangent to circle C, and we'll solve for whatever it is that they want us to solve for. So let's start with this first example. So we're given line AB, which is 10 centimeters, and we're given our radius CB, and we know that these have to be perpendicular. So if we want to find CB, one thing that we can do to make this really easy, notice that it's a 45 and a 90. That means that the other angle also has to be 45. So this is a 45, 45, 90 triangle. And in a 45, 45, 90 triangle, notice that it's also an isosceles triangle, meaning that your two angles at the base of the triangle are congruent. What that means is then that the two sides which correspond are also congruent, meaning that if one of those sides is a length of 10 centimeters, then the other side, the diameter for our circle, also has to be a length of 10 centimeters. And while that's helpful, that's not our answer. Notice that for our answer, we want to know what is the length of CB, so we want to know what is the length for our radius right here. And that should be pretty easy to find. If we know the diameter is 10, then divide that by 2. 10 divided by 2 is 5. So that would be our length for segment CB. All right, for this next example, we want to know what is the length of AC. Once again, since we have our tangent and our radius, we know that this angle has to be a right angle. So we've got two of our sides of our triangle. We're missing the third side to our triangle. And so when that's the case, we're going to go ahead and use Pythagorean theorem. And since that's the hypotenuse, we'll go ahead and call that side C for right now. For A and B, doesn't matter which ones you pick. We'll let A be 15. We'll let B be 8. So remember, Pythagorean theorem is A squared plus B squared equals C squared. So A squared is going to be 15 squared, plus B squared is going to be 8 squared, and that needs to be equal to C squared. So then 15 squared is 225, plus 8 squared is 64. Again, that has to equal our length C squared. So then we'll go ahead and add those together. 225 plus 64 is going to be 289, and that's going to be equal to C squared. So then to get C by itself, we'll go ahead and take the square root of both sides of our equation. So C is going to be equal to square root of 289. And now let's go ahead and put that into a calculator, and we'll see if it simplifies completely or if we'll have to do a little bit more work on our own. And fortunately for us, it is going to simplify completely. The square root of 289 is 17. So there's going to be our length for C. And C was our segment AC. So we can go ahead and write that that would be our answer. So that would be 17. And then make sure to include your label, which was centimeters. And there's your final answer. Okay. For this next example, we want to find CB. So notice that once again, we've got kind of our right triangle that would be formed between our radius and our tangent line. And this time we have an angle and a side. And so when that's the case, this is actually going to be a problem where we're probably going to want to use SOHCAHTOA. So remember, SOHCAHTOA is where we use our trig ratio, sine, cosine, and tangent. So let's look at our angle of 55 degrees and decide which of our sides we're given and which of our sides that we want. So compared to 55 degrees, 9 would be our opposite side. And CB is the side we want. That's going to be this side right here, which is going to be our adjacent side. Which, just for the sake of kind of making this easy to solve for, we're just going to call that A for right now. So if we've got opposite and adjacent, that's our clue to use the tangent, because opposite and adjacent, O and A, would go with tangent. So we would take the tangent of our angle, so the tangent of 55 degrees, and set that equal to our opposite side, which is 9, divided by our adjacent side, which is A. So then to solve that equation, to get A by itself, remember, since it's in the denominator, this is where we swap that with the tangent of 55, and we would say that A is equal to 9 divided by the tangent of 55. So now it's just time to type that into a calculator, so let's go ahead and do that now. We'll take 9 divided by the tangent of 55 degrees, and that's approximately 6.30. So we'll go to 2 decimal places. So 6.30 is our length for A. So then that would be our length for CB. And so 6.30 centimeters is going to be our answer. Okay. In this last example, we want to find length FA. What we're going to do is something kind of similar to what we did on the second example, is we're going to go ahead and look for this distance of AC first. So again, we're going to look for the entire distance from A to C, and then from there, we'll look for just the distance from A to F. So to get that length from A to C, that is our hypotenuse, so that is going to be our C value, because notice we've got our other two sides, so this is going to be another Pythagorean theorem problem. So we're going to have A squared plus B squared equals C squared. C is what we're looking for. Doesn't matter what we pick to be A and B. I'm going to let A be equal to the 6 and B be equal to the 8. So that would be 6 squared plus 8 squared is equal to C squared. Now we'll go ahead and simplify that. 6 squared is 36. 8 squared is 64. Now we'll go ahead and add those together. So 36 plus 64 is 100. It's equal to C squared. And now we'll go ahead and take square root of both sides of our equation. And so C is equal to the square root of 100, which is a pretty easy one to do even without using a calculator, to know that C is going to be equal to 10. So keep in mind that's the length for this entire distance right here. So it is a length of 10 from A all the way over to C. But we really don't want that entire distance. We really only want to go from A to F or from F to A. So what we want to get rid of is this length right here, which notice is a radius for our circle. And we actually already know what the radius for our circle is. We know that the radius for our circle is 6. So then to find FA, if we just take 10 minus 6, 10 minus 6 is 4. That's going to have to be our length for FA, and there's our answer. Okay, so let's talk about a couple more properties, and then we'll go ahead and be done with our notes for today. So next, let's go ahead and talk about kind of the converse to our previous theorem, which is deciding whether a line is tangent to a circle. So if a line is perpendicular to a radius of a circle at its endpoint, then the line is tangent to the circle. So if you remember, what we were saying before was that if you had a tangent, then it was perpendicular. Now we're saying if it's perpendicular, then it has to be a tangent. So really what it comes down to is checking to see if this is in fact a right angle. And probably the easiest way to do that is to just check if the Pythagorean theorem is true or not. So again, what we can check to see is the Pythagorean theorem true. If the answer is yes, that means that it is a tangent line. If the answer is no, then it's not going to be a tangent. Okay, so let's look at it for this example first. So in this particular example, our hypotenuse is going to be the 17, since that's across from our right angle. Again, doesn't matter what we pick to be A and B. And then we'll go ahead and put those into our Pythagorean theorem, which says that a squared plus b squared equals c squared. So that would be 9 squared plus 15 squared is equal to 17 squared. And then we'll go ahead and square each of those numbers. So 9 squared is 81, 15 squared is 225, and 17 squared is 289. And then on the left side, if we take 81 plus 225, that's going to be 306. And 306 definitely does not equal 289. That means that the Pythagorean theorem is not true. That means that this is not a tangent. So again, line AB, I think is what they called it, is not tangent. Okay, for this next example, we need to do a little bit of work first to kind of get everything set up. Notice that it gives us kind of two of our lines, and actually gives us, does not give us the third line, but we can find that pretty easily. Notice that it says that 8 centimeters is this distance right here, and both of these are congruent, meaning they both are 8. If we take 8 plus 8, that tells us that our distance out here is 16. So again, we want to check to see if this is in fact a right angle. So let's go ahead and set this up. Again, the longest side, our hypotenuse, has to be C. What you make A and B doesn't matter. I'm going to let A be the 8 multiplied by the square root of 3, and B be equal to 8. So again, let's check Pythagorean theorem and see if it is true. Okay, so putting those numbers in, we'll have 8 multiplied by the square root of 3 squared plus 8 squared is equal to 16 squared. So for the first one, 8 square root of 3, what we're going to do is we're first going to take 8 and square it, which is 64. We're then going to take the square root of 3 and square it, which is just the number 3. Then we'll go ahead and simplify the rest. So 8 squared is 64. And then 16 squared is 256. So then let's go ahead and simplify a little bit. 64 multiplied by 3 is, let's see, 192 plus 64 is equal to 256. And then adding those together, 192 plus 64 is 256. So we do end up with 256 equals 256. They are in fact equal to each other. What that means is that line AB is in fact a tangent line. Okay, for our next property, we're going to talk about what happens when you have two tangents which form a point and it is exterior to our circle. So if two segments from the same exterior point are tangent to the circle, then our two segments are congruent. In other words, looking at this diagram, if you've got your circle with center P and you've got your two lines which are tangent, then what that means is that line segment AB has to be congruent to line segment BC. So again, AB must be congruent to BC. Okay, so let's use that to help us with a couple of examples. On this first example, we've got our circle with center C, and then we've got our line segment RS and our line segment TS. And so using that information that we know, that tells us that these two line segments have to be congruent. What that means is that they have to be equal to each other. In other words, 25 has to be equal to 2x plus 3. And then from there, it just becomes a normal equation where you're solving for x. So we would go ahead and subtract 3 from both sides. So that would be 22 is equal to 2x. And then just divide both sides by 2 to get that 11 is equal to x. We can do that same thing on this next example as well. So notice that we've got our two segments, and so we're going to go ahead and set those equal to each other. So x plus 12 gets set equal to 4x plus 9, and now we just solve for x. And so let's go ahead and subtract x from both sides. That's going to give us 12 is equal to 3x plus 9. Then we'll go ahead and subtract 9 from both sides. So 3 is equal to 3x. And then go ahead and divide both sides by 3. And that's going to tell us that 1 is equal to x. Okay, just a couple more examples using that property, and I think that that is going to be it for us today. So it asks us to find the indicated measure. It tells us that lines that appear to be tangent are in fact tangent. Okay, so let's start with this first example. Let's kind of fill in everything that we know. So we know that AC is equal to 18. So again, that would be the distance from A to C. So that entire length is 18. It tells us that C to E is 30 and that A to F is 10. Okay, so using that information, let's go ahead and fill in some more information. If we know A to C, what I'm highlighting here in blue is 10. And using that property we just talked about, that also tells us that AB is equal to 10 as well. So where that can be kind of helpful is if we know that that's 10 and that the entire side AC is 18, and what I'm highlighting in red here would have to be 18 minus 10, which 18 minus 10 is 8. So that would have to be our distance here. And if that distance is 8, then that means this distance from C to D also has to be 8. So if we do that one more time, C to E is 30, C to D is 8. So if you take 30 minus 8, then this distance right here has to be 22. That means that this distance right here also has to be 22, which actually is the distance that we wanted. So remember, we wanted to find FE. So F to E is right here. That is, in fact, going to be equal to that 22. And then just don't forget your label. These were all in terms of centimeters. So that would be 22 centimeters. And there is our answer. Okay, let's do something kind of similar with this next example and see if we can't find FE here as well. So we're told the perimeter is equal to 40, and we'll end up using that a little bit later on. Let's use our other information first. So we're told AC is equal to 15. So that would be the entire distance from A to C, 15 right here. We're then told that AF is equal to 8.5. So again, this distance from A to F is 8.5. So if we know that that distance is 8.5, then that means that we also know that this distance is 8.5. And if that distance is 8.5, then if you take 15 minus 8.5, then that means that this distance has to be 6.5. That means that this distance right here, so again on the corners, they have to be equal, also has to be 6.5. So then what we don't know is we don't know what these two line segments are just yet. We don't know what FE is, and we don't know what DE is, but we do know that they're equal to each other. I'm just going to call those X. So here's the part where we're going to use the perimeter. Remember, the perimeter is what all the sides would have to add up to be. And if we add up each of the different pieces individually, that would be 8.5 plus another 8.5 plus 6.5 plus another 6.5 plus our two x's, so plus x has to add up to be our perimeter, which is 40. So then let's go ahead and simplify just a little bit. If we take 8.5 plus 8.5 plus 6.5 plus 6.5, that becomes the number 30. And then x plus x is 2x, so 30 plus 2x has to equal 40. So now we just have to solve for x. So let's go ahead and subtract 30. So that gives us 2x is equal to 10. So now to get x by itself, just divide both sides by 2, and we get that x is equal to 5. Now x, remember, is the same as FE, which is in fact what we are looking for. So we can also say if x is 5, that FE is equal to 5. And then once again, our label was centimeters. So 5 centimeters is going to be our answer. All right, guys, I think that's all we've got to talk about for today, our properties of tangent lines. In the next section, we're going to talk about what are called central angles and arcs. Until then, have a great rest of your day.